They build strong family bonds and actively participate in raising their offspring, passing down essential survival knowledge. They have their own language, which varies by region. In moments of danger, they help each other and show a high degree of empathy. They skillfully use tools to solve problems and can plan several steps ahead. Do you think we're talking about humans? But in fact, we're talking about dolphins, some of the most remarkable creatures on our planet. Today, you will learn: how do groups of dolphins manage to move in perfect sync, even with their eyes closed? How far have humans come in understanding dolphin language? And what progress have dolphins made in interpreting ours? And finally, can dolphins feel sadness? All this and much more in today's video. Are dolphins really that smart? Don't forget to like and subscribe to our channel for more fascinating content. The first factor indicating dolphins' remarkable intelligence is their brain size. This principle naturally follows from evolutionary analysis. The more complex an animal's physiology, the larger its brain size relative to its body size. Scientists have even come up with a special encephalization quotient, which determines how many times an animal's brain mass exceeds the average norm for its weight category. For humans, this value is between 7.4 and 7.8, which is the highest among all living beings. The second highest result, 5.3, belongs to bottlenose dolphins. But things aren't that simple, and the encephalization quotient alone is not the only criterion that would allow us to conclude that dolphins are the most intelligent creatures after humans. What's equally important is the brain's structure itself. Neurobiologist Dr. Lori Marino used tomography to study dolphin brain activity and compare it to some other animals. It turned out that, just like humans, a large portion of the dolphin brain consists of neurocortex, which is responsible for higher mental functions. In most mammals, the neocortex is barely developed. Furthermore, the dolphin neocortex is highly convoluted, which is also characteristic of the human brain. This feature significantly increases the neocortex's surface area and facilitates numerous connections between neurons. Moreover, scientists have discovered spindle neurons, or von Economo neurons, in dolphins. In humans and primates, these neurons are associated with emotions, social interactions, spatial orientation, and the ability to empathize. But does having a large and complex brain alone necessarily indicate high intelligence? Today, most scientists agree that behavior should also be considered an indicator of intelligence within a species. And here, dolphins actually have a lot to show off. For instance, dolphins can plan and trick. This trait was observed at the Institute for Marine Mammal Studies in Mississippi with a dolphin named Kelly. Here, dolphins were trained to collect trash that fell into the pool and hand it over to the trainer in exchange for fish. But Kelly took this a step further. When she saw a piece of paper in the pool, Kelly grabbed it and hid it under a rock at the bottom. When the trainer arrived, Kelly would discreetly tear off a small piece of the paper and hand it over. She would receive her well-deserved treat and then dive back down to tear off another piece of paper. Remarkably, the dolphin realized that a large sheet of paper would earn her the same reward as a small one. So, she could simply divide a large piece into several small ones and get more fish. But Kelly's cunning knew no bounds. The larger Kelly's catch in the pool was, the more generous the trainer would be. One day, after accidentally catching a seagull in the pool, she received a large amount of fish. Then she began hiding some fish at the bottom of the pool to use later as bait for seagulls. Kelly began catching seagulls to receive a generous reward from the trainer. Later, Kelly taught her calf this clever trick, and he, in turn, taught the technique to other dolphins. Soon, catching seagulls using fish as bait became a hobby among the dolphins living in the Institute's pool. Of course, these observations alone weren't enough to draw definitive conclusions about dolphin intelligence. But we've learned a lot about dolphin abilities. Dr. Stanley "Stan" Kujaz, a professor at the University of Southern Mississippi, conducted a series of experiments and discovered that dolphins possess spatial thinking and can solve problems, including collectively. The researcher's subject took very little time to solve a puzzle similar to a finger maze. The dolphin's reward was a gelatinous ball that he retrieved from the maze. Dr. Kujaz then decided to make the task a bit more challenging. He crafted a hollow container from a plastic tube and 2 caps, placing a fish inside. One lid of the container was glued on while the other fit tightly but could be opened with some effort. Both ends of the container had ropes, and pulling both simultaneously would open the container. The dolphins had to solve this problem without any prior training, as their favorite treat was inside. And 2 adult male dolphins managed to find a solution in less than a minute and a half. They somehow communicated with each other, grabbed the different ends of the container, and pulled the ropes in opposite directions. The container opened, and both dolphins gained access to the fish. Dolphins also excelled in passing the mirror self-recognition test, the MSR test. How is this test conducted? An animal is placed in front of a mirror after a researcher marks its body, usually on the face or forehead, in a spot it cannot see without the mirror. The animal must see its reflection in the mirror and notice the mark. If the animal tries to touch the mark on its body using the mirror for guidance, this is interpreted as evidence that it recognizes it is looking at itself, not another animal. This behavior is considered a sign of awareness, the ability to recognize one's self as a separate individual. However, the skill of recognizing one's self in a mirror develops gradually. First, there is a period when the mirror is introduced to the subject. The next stage involves the animal performing repetitive actions to see how the mirror reflection copies them. The final stage is when the mirror is used to view something that cannot be seen without it. 2 psychologists and marine scientists, Diana Reese and Rachel Morrison from Hunter College in New York, found that dolphins recognize themselves in a mirror as early as 7 months of age. Even humans acquire this skill a few months later. Children typically begin recognizing their reflection in a mirror around the age of 1. This recognition involves freezing in front of the mirror, spinning, making faces, and observing how their movements are imitated by their reflection. The researchers believe that dolphins develop this ability so early on due to their need to quickly acquire social skills. Dolphins must integrate into a group and instantly recognize each other from birth. Humans and terrestrial mammals do not require such early socialization, which is why this skill appears a bit later. However, dolphins passed the mark test when they were 2 years old. They might have been able to do it earlier, but the rules of the aquarium prohibited marking marine animals until they became at least 2 years old. Mirrors were installed in the pool, and several dolphins were marked with non-toxic ink. As a result, the marked bottlenose dolphins repeatedly swam closer to the mirror, twisting and turning to get a better view of the marked area. In contrast, the non-marked dolphins spent much less time in front of the mirror. Dolphins need synchronized actions, not just to entertain the public in dolphinariums. They often hunt in large groups and coordinate their actions to drive rivals away. Using underwater microphones and cameras, marine ecologist Kelly Benoit Bird and Whitlow W.L. Au, a professor at the Hawaii Institute of Marine Biology, managed to track dolphins' hunting behavior near the Hawaiian island of Oahu. First, the dolphins search for prey in a tight formation. Once they find a school of anchovies or a group of shrimp or squid, they form a circle and start spinning in a dance, creating a wave. The prey clusters into a tight ball, and then the dolphins pair up to take turns feeding. A strict feeding order is crucial to prevent the fish from escaping. Interestingly, the dolphins take turns in a clockwise direction. Then, they come up to the surface in the same formation to take a few breaths together before continuing their feast. All of this takes place in complete darkness at night, when the dolphins cannot see each other or their prey. So, what helps them move so synchronously? It turns out that dolphins communicate with each other during the hunt. Sophisticated hydrophone equipment detected sounds resembling clicks, whose frequency increased dramatically in the last few seconds before the hunt began. Moreover, these clicks were narrowly focused signals. It's not certain that this is how dolphins talk to each other. The clicks may be used for echolocation, to determine the location of objects underwater by emitting sound waves. The narrow focus of the signal could be explained by the dolphins' desire to avoid being overheard by other marine creatures or dolphin groups and losing their prey. By the way, dolphins have plenty of hunting tricks up their sleeves. For example, in 2003, a curious hunting behavior of bottlenose dolphins was caught on video off the coast of Florida. The dolphins split into two groups. The first group started moving in a circle and slapping their tails, stirring up mud and sand from the bottom. The fish caught in the muddy trap tried to escape and began jumping frantically out of the water, where the second group of dolphins waited with their mouths wide open. No one even needed to catch their prey. It jumped straight into dolphins' mouths all by itself. Once again, this clearly demonstrates teamwork. For a long time, it was believed that only Florida dolphins hunted using the mud ring technique. However, similar behavior was recently observed among dolphins in the Caribbean. Of course, such an advanced creature as the dolphin can find food on its own without the help of its peers. And yet, depending on the location, the dolphin's hunting method can vary greatly. For instance, in the Bahamas, bottlenose dolphins literally bury their noses in the sand to search for fish. This creates a crater in the sand, and after a while, the dolphin triumphantly emerges from it, holding a fish in its mouth. What else can dolphins do? They are excellent at whistling, and they don't just do it out of boredom. In 2013, Dr. Stephanie King and Dr. Vincent Janik from the University of St. Andrews in Scotland published a study showing that dolphins use unique whistles to identify each other. Each dolphin has its own signature whistle, which it responds to and knows from early childhood. The researchers recorded the whistles of each dolphin and then played them back using underwater speakers. They played not only the sounds that the dolphins responded to, but also the sounds of other animals they had never seen. The dolphins ignored all sounds different from their call sign, but recognized and repeated their signature whistle. If there were a translator from dolphin to human, this equipment might look like this: Adam, Jacob, Michael, Thomas, Flipper. Flipper, that's me, I'm here. It seems that the call sign helps dolphins distinguish between friends and strangers and stick with their own pod. After all, these cetaceans have no other way to orient themselves. Marine creatures live in an environment where they can move freely in any direction, up, down, forward, backward, and sideways, without needing any surfaces. Unlike humans, they can move in 3 dimensions without any limits imposed by surfaces or gravity. Most of the time, they cannot see each other or find one another by scent. In the wild, they do not have a permanent home to return to and constantly migrate from place to place. But humans wouldn't be humans if they stopped trying to find a way to communicate with dolphins. Nearly 50 years later, researchers Denise Hertzing from Florida Atlantic University and her team developed a special device called CHAT to facilitate communication between humans and cetaceans. How was it invented? It's actually quite simple. For 5 months a year, the researchers' team studied a pod of Atlantic spotted dolphins near the Bahamas. The dolphins got used to the researchers and began imitating human sounds and poses, even inviting them to play together. The dolphins' behavior inspired Hertzing to create an underwater keyboard with several buttons where each button represented a specific object. When pressed, the device would emit a sound corresponding to that object. In simpler terms, a person with the device needs to get a response from the dolphin about which toy it wants to play with, such as a scarf, rope, or a piece of seaweed, and then provide the toy and play with the dolphin. Once the dolphins master these 3 sound combinations, the researchers can continue building a vocabulary of whistles. It could form the basis of an artificial language that may allow humans and dolphins to communicate with one another in the future. Since 2010, scientists have continued to work on the second phase of the experiment. The main part of the electronic system is a device the size of a smartphone that can record dolphin sounds, interpret them, and generate sounds in response. For 40 years, Dr. Hertzing has been studying dolphins, recording and preserving every audio and video interaction. The scientist now believes that AI tools and new advances in machine learning will make it easier to crack the code of dolphin communication. Admittedly, dolphins are still not very good at imitating human language. However, these cheerful creatures more than make up for it with their ability to imitate human movements, even with their eyes closed. During an experiment, an Atlantic bottlenose dolphin named Tanner showed excellent results. First, Tanner, who lives in the Dolphin Research Center in the Florida Keys, successfully repeated the actions of another dolphin without actually seeing it. Then, with a blindfold on, the bottlenose dolphin also flawlessly mimicked the movements of a trainer in the water. Kelly Giacola, the director of the Dolphin Research Center, does not know exactly how Tanner manages to accurately imitate the actions of other people or animals. Perhaps Tanner hears the sound accompanying the action or uses echolocation. One thing is clear: Tanner excels at this task. Humans certainly aren't capable of this, but we still have a lot in common. For example, dolphins coo with their young, just like humans. Marine biologist Leila Saig took 34 years to uncover this behavior. Throughout this time, she studied bottlenose dolphins in Sarasota Bay, Florida, and noticed changes in a mother dolphin's whistle when her calf was nearby. They emit whistles with much higher maximum frequencies. Scientists suggest that this cooing may help to teach the young or establish social bonds. Moreover, this might be a way for the mother to teach the calf to recognize her among others. There is also evidence that dolphins can grieve, just like humans. To determine if this is true, researcher Giovanni Berzi's team from the Dolphin Biology and Conservation Group collected and analyzed 78 observation records of dolphins over 46 years, from 1970 to 2016. The scientists noticed changes in the behavior of dolphins, especially females, upon the loss of their calves. A mother was often unwilling to part with her deceased baby, sometimes carrying it on her back or keeping its body afloat for several days, as if waiting for a miracle. There is also a documented case of dolphins living in captivity who lay at the bottom of the pool and refused to eat for several days after the death of a friend. But dolphins aren't the only animals with rituals for the dead. Some other species have their own traditions. Be sure to check out our video about crows and see what they do in the face of loss. In short, no matter how you look at a dolphin, it is unique and incredibly smart. But what if this mammal has been inappropriately put on a pedestal and idolized? What if dolphins are not as intelligent as previously thought? Indeed, there is such an opinion among scientists. For example, Paul Menger, an anonymist and researcher from the University of the Witwatersrand in South Africa, believes that dolphins' large brains have nothing to do with intelligence and serve only to retain heat. He even unfavorably compares dolphins to goldfish, pointing out that when goldfish are placed in a tank, they try to escape by jumping out of the water, while dolphins, caught in nets, do nothing to save themselves. Menger even described the tricks that dolphins perform as simple expressions of their feeding instincts. You jump through a hoop, you get the food. He also questioned the mirror test, arguing that dolphins displayed the same behavior regardless of the mirror's presence. Still, the studies mentioned earlier show that dolphins are not that simple. But can they really be considered the most intelligent living creatures on the planet after humans? This question seems to remain open for now.